All right, I had a subscriber ask me if I could do a video on piecewise functions. So I don't teach piecewise functions in my class, but I would be more than happy to show you this video online. So piecewise function, what does it mean? It means our domain numbers, our x values, okay? At different intervals, we can have different functions. So this is 3 different functions for this piecewise function. Anytime x is less than 0, we're using the rule of x plus 2. Anytime x is a value that is greater than or equal to 0 or less than or equal to 1, we're going to be using 3. It's just an automatic. We know the value is going to be 3 for y. Okay? And then we're going to use negative x plus 1 as our rule or our function when anything is above the value of 1. So we're going to have 3 different things happening on one graph given the piecewise function. Let's start with x plus 2. So any numbers less than 0. So I'm just going to pick some values less than 0. I'll plug those in right here to see what my y would come out to, and then I can plot the point. So numbers less than 0, I don't know, negative 7. So if I had negative 7, which is less than 0, negative 7 plus 2, that would give me a positive, or excuse me, that would give me negative 5. So negative 7 plus 2 would give me negative 5. So I'm going to go to negative 7 down to negative 5, and I'm going to mark my first dot. Okay? Next, what I'm going to be doing is, let's just do negative 6. Negative 6 plus 2 is going to give me negative 4 right here. Negative 5 plus 2 is going to give me negative 3. And we notice that we have a pattern happening, right? We are creating a straight line, and this is my function. Now, notice that x plus 2 is only for values less than 0. I'm not including a value of 0. It has to be less than 0. So at 0 for x, I need to put an open circle because we are not including that value, but anything beyond is a part of it. So I'm just going to fill out all of those right here and then create my line like so. So I've created part of the piecewise function. I went all the way up to values less than 0. I don't include when x is 0 here with an open circle. That's what that's telling me. Now over here we are going to include 0 and we are going to include 1. So x, if it's greater than or equal to 0 or less than or equal to 1, the y will always be 3. So when we're on 0, I go up to 3 and I'm going to give a closed circle because I want to include that. And I want everything when x between 0 and 1, we should include the value of 3. So I'm going to have another dot right there, and I'm going to connect with a line. So from 0 to 1, that's what we would be graphing right there. And finishing it off, my last function in the piecewise function is negative x plus 1 when x is greater than 1. So when x is greater than 1, okay, so if x was 1, I need an open circle there with what I would get. So when x is 1, I put a 1 right there. I have negative 1 plus 1, which gives me a 0. I need to put an open circle at 0 on the y when x is 1. I'm not including it. It has to be greater than 1. So I'm not including it, but where do we go from there? Pick another number, 2. If x was 2, which is greater than 1, negative 2 plus 1 would give me negative 1. 3. Negative 3 plus 1 is negative 2. And notice we have another pattern happening as we're going down the line. Once you get enough to where you're happy, draw your line. And this is an example of a piecewise function. We're going up, rise 1, run 1. We would be crossing at 2 on the y-axis, but we're not including that because we're not including the value of 0 for x. We are including the value of 0 all the way through the value of 1 here, where the function tells us it should just be an automatic 3. And then our final function, a negative slope starting up at 1. Notice if this line were to continue, it would cross right on the y-axis at 1 where it should. We're going down 1 because that's the slope of that function. Hopefully this makes sense. Study hard and good luck on your upcoming tests. Just remember, do them one at a time and you'll be done.